Hey guys, welcome back to your learning journey in this machine learning. And my name is Nachiket Murthy, and I'll be with you in your learning journey today. So, folks, in the last few videos, we have understood the basics of machine learning, the difference between AI, machine learning, and deep learning, and the key terminologies involving machine learning, types of machine learning. And then at the end of the last session, we have also looked into the two tasks that we can do in case of supervised machine learning, that is regression and a classification task. Now, as we progress in today's session, we will look into the one of the important and a very common machine learning algorithm that's called as a linear regression algorithm. First and foremost, this linear regression algorithm comes under the supervised machine learning. So what it means is, when I'm applying a linear regression model, it would clearly mean that in my data set, I've got the features as well as the target. So both features and the target are presently with me. And also here, this linear regression model, I'll be using it in case if I want to perform the activity of regression. Now, what is regression? Well, as we have studied in the last session, regression is a task where the target or the label that we have got in my given data set, it is actually real value. And that is what a regression task is. So, this linear regression model is what we use it to perform the task of regression, where in this scenario, we are trying to predict the unknown value of a variable which is continuous in nature. Now, I want to predict this relationship between my input and the output, where the output is continuous in nature. And here, I'll be trying to establish a relationship with the help of an equation, which is given by y is equal to a plus bx. So if you look into this equation that I've got, this equation is what we call it as the simple linear regression algorithm equation. So it clearly represents the relationship between the input and the output. So I'm trying to represent the relationship between the independent variable and the dependent variable with the help of this equation. Okay, and you know already what exactly are these terms would mean. So just to give you a quick recap. So here in the scenario, so the features is also actually known as the independent variables. The labels are actually the target. Okay, so labels is the target. Okay, so in the scenario of regression, we are trying to establish a relationship between x and y, where x are the features and y is my target. And in this scenario of regression, the target value is continuous in nature. Now, before we dive deep into this equation, let's try to understand in a very simple way about what exactly is this linear regression. Well, let's understand it with the help of an example. Let's say we have a area. Okay, we have a area over there, and in this area, okay, we've got different houses. Okay, I've got different houses. Okay, I've got the houses belonging to the different people. Okay, or there I've got various houses that are present with me. Okay, now these are the houses, and this is how the houses are present in an area. Now, when I have the houses present in an area, and let's suppose I am a politician and I'm interested in developing this area. Now, if I want to develop this area, I can develop any area by providing a connectivity. So let's say that I want to construct a road for all these houses. So I want to construct a road. So when I say I want to construct the road, so it is nothing but I'll be interested in creating a road. Okay, I'll be interested in creating a road which passes through all of these houses, or I am interested in creating a house where all these houses, okay, all these houses are near to the road. So that is when all these houses can benefit with the road that I'm planning to construct. So the key thing that you have to remember is I'm interested in connecting all these houses by the roads, which means I'll have to place a road such a way that, okay, all the houses are nearest to the road. Okay, somewhere along this arrow that you're seeing right now. So this is what I can say that as a regression task. Now you might be wondering, how is it connected? Now, how is this example is connected to the linear regression? Well, let's understand in detail about as how it is actually connected. See, in order to understand this an example, let's go ahead and represent these houses in the format of a data points, and we'll also try to understand what is the structure of this equation. Now, in order to understand this, I'm going to launch a browser and we'll go to the site. Okay, we'll just start by getting some data points. So here I'll start by generating some data points. Let's say these are the various data points that I have with me. So assume these are the various data points that I have with me. Okay, individual data points represents the individual house. Now here, in case of supervised machine learning, I have mentioned that we'll be representing the information between the input and output with the help of the equation y is equal to a plus bx, and this is the simple linear regression. So how does this equation would represent if I mention it in a mathematical manner? Now, for demonstration of this, I'm going to mention as y is equal to 2x plus 2. So if I say y is equal to 2x plus 2, so you can clearly observe that this equation of y is equal to 2x plus 2 is represented with the help of a straight line. And if you think about it closely, this is in the format of y is equal to, yes, y is equal to, it is in the format of a plus bx. So I'll mention one more equation. Okay, this time I'll mention as a plus bx. So I'll say y is equal to 3 plus 1.5x. See, this is another straight line that I've added, which is in blue color. So in general, okay, in general, when I say simple linear regression, it is nothing but the equation of the line. It is a equation of the line. Now, if I change the values of a and b, in the first example, the a is 2 and b is 2. In the second example, a is 3, b is 1.5. And let me give one more example. A is equal to minus 2 minus 2x. See, this is one more example where a and b both are equal to minus 2. So by changing the values of a and b in this equation, I can get the various straight lines as you have seen in this example. Okay, now let's connect back to our earlier scenario where I want to draw a road, or I want to construct a road which passes through all the houses. In other words, I'm interested in drawing a straight line which passes through most of the data points. So that is what I'm interested in. In other words, let's go ahead and draw it itself. I think that will be a better way. So I'll go ahead and draw a straight line. So I'll be interested in drawing a straight line. As you can see, okay, this is a straight line that I'm interested in. So as you can see, I've just drawn a straight line which passes through most of the data points. Now, interestingly, if you just go ahead and look into the way in which this line that I've drawn is representing it, I'll just select this line and I'll display the overall value and the equation. See, if I display the value, it clearly says that y is equal to 0.9966x minus 1.0067. So in other words, even this is also representing a straight line which is of the format of y is equal to a plus bx. So by changing the values of a and b, Okay, by changing the values of a and b, I can modify as how my equation of line would look like. Now my goal is draw a straight line which passes through most of the data points. Now you might be wondering, why is it actually required for me? Now why can't I just go ahead and draw the straight line? Well, that's where the first class comes into picture. See, in the first class I have mentioned that in case of machine learning, I want the machine to learn the pattern in the data set. Now in this scenario, okay, let's say for a second I'm going to remove that line. So let's say for a second that I want to explain the pattern that I've got on this set of data points. Now if I want to explain the pattern that is present in the set of data points, I should be able to summarize it with the help of somewhere a tangible value, isn't it? Well, obviously I can make use of a mean and other statistical mean to explain the data points, but that will not help me to explain the overall pattern. So in order to explain these set of data points with the help of an overall pattern, I have to make use of mathematical equation. So what I'm trying to understand is, with the collection of data set points, I want to understand the overall pattern such that whenever I've got a new data, let's say this is the new data that have got J1 that you see right here. When I have this data point of J1, I can say how far this data point to the line, or how far is this data point to the line, or how far or how closer to the data point. So I'm interested in analyzing this pattern, and that is what a machine learning is. So for understanding this pattern in my data set, we make use of machine learning algorithm. And when we talk about the machine learning algorithm is a mathematical equation. Now in this scenario of the supervised machine learning algorithm, the mathematical equation is given by y is equal to a plus bx. Here y is known as the target variable or a dependent variable, or in your scenario you can also think of it as labels, and x is my input, features or the independent variables. And in this equation of y is equal to a plus bx, a is called as y-intercept, b is called as the slope of the line. So here, constructing a road which is closer to all the houses is very similar to the linear regression equation that I have just explained. Okay, I've got a data set. For this given data set, if I want to find the pattern using this simple linear regression algorithm, I have to find the values of a and b. So in this scenario, okay, what will be the input for the supervised machine learning algorithm? Well, the inputs are x and y. Okay, my x and y are the inputs. What will be the output of this linear regression algorithm? Well, the outputs are a and b. Okay, so this is what you have to remember in case of machine learning algorithm. So we will provide the inputs as the data itself, and the outputs is the parameters of that algorithm. Now if you consider the traditional approach, so in case of traditional programming approach, so think about it. In case of traditional programming approach, I will have something as an input. Okay, I'll have the input as x. Now with this input as x, I will be finding the output. That means as a developer, I'll say that y is equal to 2x plus 2. I will mention this equation, okay, as a developer. Now when I have a new data, okay, let's say when x is equal to 5, I'll just substitute this value in place of x and I'll get the output. But in case of machine learning, I will send x and y, this value 2 and 2 that you see right here. So those are the values that I want to find. So that is the main difference between the machine learning and the traditional programming. In case of supervised machine learning of simple linear regression, this is given by the equation y is equal to a plus bx. Okay, y is equal to a plus b into x. So a is a y-intercept, is a slope of a line. Now in case of multiple features, which is also known as multiple linear regression. So in such scenarios, the equation is given by, so we'll generally mention the equation like this. So y is equal to, so w1 x1 plus w2 x2 plus w3 x3 up to wn xn plus c. Okay, so this is the equation of linear regression for the multiple features. So the key takeaway from this video is, in case of linear regression, the target value will be the continuous value, and the relationship between the x and y is represented with the help of y is equal to a plus bx, considering I have a single independent variable. Okay, so with this equation, we will find the relationship between x and y, and then if I have got multiple features, this is expected with the help of this equation. Now with this basic understanding and the general concept that you are aware of in case of machine learning, what we will do in the next session is we are going to see how we can implement this flow of machine learning on a very simple data set, so that you can get a visual understanding about what is machine learning, especially on this supervised machine learning, how exactly these parameters are found. We'll also look into the mathematical intuition as well. Okay, I hope you are excited for the next video. So I'll see you next time.